Welcome once again. Here we are in lecture 13. And what I'd like to do is pause and kind of review and take a breath because I know your heads are all exploding. Okay? So, first, let's look at our equations we've had up to this point in the kinematics, after kinematics with other things with energy and forces. We had kinetic energy, 1/2 the mass times the velocity squared, potential energy, gravitational potential, mgh, the weight times the height. Total energy, just combine kinetic and potential. Linear momentum is the mass times the velocity. The centripetal force, mv squared over r. Take away the m, and we have the centripetal acceleration going around in a circle. We'll do problems with all of this. I'll show you the problems that I'll ask in a bit. First, let's review the so-called diver problem, okay? And I'll give you a chance, of course, you can pause and do the problem. Consider a 50-kilogram diver standing on top of a cliff with a total energy of 40,000 joules, okay? And the first question is, what is the height of the cliff? And then I want to know what her speed is when she's halfway down. So again, we have a diver. There she is, brave diver. Okay. On top of a cliff, and we want to find h. We want to find the height of the cliff. Well, we're going to use the conservation of energy. And what that says is that her total energy will not change. Okay? Now remember, her total energy can take different forms. On top of the cliff, top of cliff, I hope you all agree that her velocity is 0, therefore her kinetic energy is 0, therefore her total energy, which we said was 40,000 joules. Remember what a joule is? Kilogram, meter squared per second squared. This must be equal to all potential energy. So it's equal to mgh. M is the mass, g is the acceleration due to gravity, and h is what we're looking for. So we want to find h. Okay. 40,000 kilogram meters squared per second squared is equal to mass, we said was 50 kilograms. G, we're taking to be 10 meters per second squared, and then we have h. Now remember, we're looking for h, and what that means is all the units should cancel, and we should just be left with units of height, and for us, that's going to be meters. We see we have kilograms on this side, we have kilograms on that side. We have meters are going to go out with one of these meters, and second squared is going to go out with second squared. On the right-hand side, then, we have 500 h is going to be equal to 40,000 meters. Okay? Remember, one of the powers of meters went out. So h is going to be 40,000 divided by 500, and that answer should be in meters. We can take 2 zeros away. Now we have 5 into 400, I believe, is 80 meters. So the height of the cliff is 80 meters. Part A, done. Part B, what is her speed when she's halfway down? Well, what's her total energy when she's halfway down? Well, her total energy, remember, by conservation of energy, does not change. So her total energy is still 40,000 joules. But now, when she's halfway down, that 40,000 joules that was all potential energy at the top is now half potential and half kinetic. So, I'm going to erase halfway down. Oops. Halfway down, her kinetic energy is going to be 20,000 joules. Half. It's half of what it started with. And that must be equal to 1/2 mv squared. Okay, once again, we know the mass, we need to find v. Okay, 20,000 joules, kilogram, meters squared per second squared is equal to 1/2 times 50 kilograms. Okay, we take kilograms out, times v squared. Okay, I'm going to multiply both sides by 2, get rid of the half. Okay, I have 40,000 meters squared per second squared is equal to 50 v squared. Oops, sorry. Now divide by 50 on both sides. I'm trying to go slow. Take away a 0. 5 into, what is that, 4,000, I guess, is what? It's 800. Okay, take out the 50. So v squared is equal to 800 meters squared per second squared. Now, when I take the square root of 800, the square root of meters squared per second squared is just meters per second, as it should be. What's the square root of 800? I don't know, and I don't really care. Well, we do care. You can use your calculator, but let's think. 20 times 20 is what? 400. 30 times 30 is 900. 800 is very close to 900, so I'll guess 27, 28. I don't care. Close enough. 28 meters per second. Good enough for me, good enough for my exams, because I won't give you anything that's too close. So you can use this approximation, okay? Great. So now we're experts on how to do these diver problems.